Now we look at three classes: member, MemberList, and this class MemberIdServer, which was not actually in the design. We will see why we needed that very shortly. So here is the member class, public class member, implement serializable, and we have this serial version UID field, name, address, phone, and ID fields. Then there is a field to store the list of books that the member has borrowed, the holds placed by this member, and the transactions for this member. So there are three linked list fields. Now, let's talk about some complication that we encountered when we implemented this. We wanted to generate a unique ID, or we have to generate a unique ID for every member. So we thought we'll have a prefix M for every member and a number that follows it. So things would, it would look like M1, M2, M3, M4, etc. That would be our member IDs. So our plan was to use static fields. So I'm typing in some stuff here. This was our plan: private static int member ID, something like this, a member ID counter, and that started maybe with 1. Okay, so we have a static field. So this is available to all member instances, right? So we thought we could do it like this. The ID could be generated like this: ID equals this constant string M plus member ID counter and member ID counter can then be incremented. So what will happen? When you create the first member, pass the name, address, and phone, then those are stored in the name, address, phone fields. Then we generate an ID, store that in the ID field by concatenating the string M plus whatever is in the member ID counter. So initially it is 1, right? We initialized it to 1. Then after creating the first member, so this is not there. This field is not there. This statement is not there. This was our original plan, right? And we increment member ID by 1. So when you create the second member, member ID counter is 2. So the second member will get M2. The third member will be given the ID M3, M4, M5. It will keep on changing for all subsequent members. So everything worked fine. But the problem was that when we serialized, this field is now will not be serialized, so it never got returned to the disks, to the disk. So when we read this back after completing a session, when we read the serialized version back, we didn't have a member ID counter at the right value. It was going back to 1. So we started assigning the same member ID for different members. There was a way to overcome it, but it was extremely tedious. It was very difficult, very ununderstandable. So what we decided was, instead of having a static field, we would have a singleton class, MemberIdServer, which would generate a member ID. So it will have It is a singleton class. So it is going to have just one field, ID counter, and it returns the value of ID counter. Okay, that is at the very heart, that is the big part of this class. Remember that it is a singleton and that it has just one instance field that is an integer, and it returns the value of that field whenever you want a new ID, and it increments ID counter by 1 every time it returns 1. So the first time you call it, it gives you 1, second time 2, third time 3, etc., etc. So this is gone now. This is gone. This is still, this is back. So this is our implementation. So what is going to happen when you need a member ID to be generated? We concatenate this string M as before, but then we call the get ID method of MemberIdServer, and that first time you call it, it gives you 1. So you have M1. Second time you call it, you get M2, etc., etc. So we are generating unique strings, unique IDs. And when you serialize, of course, all these things are serialized. We also serialize this class, MemberIdServer. It implements serializable. So this gets serialized. So the ID counter here is not static. So that gets returned to disk, and this is retrieved. This MemberIdServer is retrieved, and the ID counter is set to the right value. That is the reason why we have this MemberIdServer. It circumvents the restriction of serialization. That restriction being static members are not serialized. That is one big difference between member and book in terms of the complexity or feature. Book didn't have such an issue because the ID was supplied by the actor. Issue a book, we need to add this new book to the list of books borrowed. So books borrowed is here. So we add this book, new book, or the book to be issued to that list. And we create a transaction object with the title of the book and the type of transaction. Actually, we should take a look at the transaction class at this time. Here is the transaction class. It also implements serializable. There are 3 fields, instance fields, I mean. The type of the transaction, like book issued or hold placed and so on. The title of the book involved in the transaction and the date of the transaction. That is of type calendar. So when you create a transaction object, you have to say what type it is and the title of the book that is involved in the transaction. You don't have to say who the member is because this transaction object is going to be stored with the member object. So the member object is already known. The type and title are stored. We create the Gregorian calendar object. And remember, when you create the Gregorian calendar object, it is going to have the current date and time. So we don't have to do anything more to store the current date and time. And there are some getters here, get type and get title. And there is a getter for the date, and it is in a form that is a little more understandable than the 2-string version of date. You get the month, put a slash, the date that is in the date object, and the year. So you concatenate those using slashes. Then the other big method here is onDate. The question is this transaction on this particular date? So you're getting a certain date as parameter, and this method will return true if this particular transaction was performed on this date. So we get the year, month, and date fields of this particular object and compare it against the corresponding fields of the date stored in the transaction object. So we compare those, and if all of them compare, that means this transaction was performed on this date and we return true. Otherwise, this will return false. So that is the transaction class. Let's go back to the member class. So we here covered the issue. So we created a new transaction, stored it in the transactions list, return true. If we couldn't, for some reason, complete this addition, we return false. And we have the return book method. We have to basically remove this book object from the books borrowed list. We added the book object here, we remove the book object here, and we create a new transaction saying that the book was returned. Renew, we look for this book. This book is to be renewed. So we look for this book in the list of books borrowed. If you can't find it, you will return false. Otherwise, we look at each book and see whether the ID is the same as the ID of the book in the parameter. And if so, we renew the book. There is an iterator returned in this method, get all the books issued by the issued to this member. Then placing a hold, when you place a hold, this hold object has to be stored in the books on hold list, and we have to create a transaction. Remove hold, we go through all the transactions and check each hold against this book ID, or the ID of the book stored in the hold against this book ID. If there is a match, we create a transaction, remove the hold object. See that we are using a list iterator. Okay. Get the transactions on a specific date. So a member has the transactions stored in the transactions list. So we go through the list of transactions, and we are going to pick all the transactions on this particular date and add those transactions to a list that is created here. So we have a list created, linked list called result, and pick each transaction and see if it falls on this date. Remember, there is an onDate method in transaction that returns true if this date matches the transaction's date. If so, we add that transaction to the result, and finally we return an iterator to that result. Then there are some getters here and setters. Finally, in this video, let's look at the MemberList class. It is a singleton and an adapter. So that should account for understanding a good part of this functionality. It implements serializable. So we have a private constructor, the instance method for singleton. Then This search method is very similar to the search method of catalog. Given a member ID, we iterate through the linked list here, through this members, which is of type list, and we pick each member, see whether the ID matches. If so, we have found the member. Otherwise, we return null. Then we can insert a new member to that by invoking the add method on the adaptee. And that's it. There is no remove member functionality, so that is absent here.